This is my 8th video lesson for Unit 10. In this lesson, we'll be determining the rate law in a multi-step reaction. Go to page 33 in the class packet. Keep in mind, this topic is not on the Chemistry Regents exam. Learning target. At the end of the lesson, I'll be able to write the rate law of a reaction given a mechanism. Homework number 8 will be based off this lesson. There'll be exam based off Unit 10. Reaction mechanism is a step-by-step sequence of elementary reactions of an overall reaction. Last term we did a lab involved making oxygen gas from the decomposition of hydrogen peroxide using potassium iodide as a catalyst. Even though this reaction looks like it's one step, it is actually more complex. It is two steps. This is the reaction mechanism of this reaction, showing what is Ki doing in this reaction. These two steps are elementary reactions, which are single-step reactions. Therefore, this overall reaction is known as a multi-step or complex reaction, which consists of two or more elementary reactions. In the multi-step reaction, this is the reactant and these are the products. If you look at the chemical mechanism, there's a molecule that is not a reactant and not a product. This molecule is an intermediate. Intermediates are molecules formed in the middle of a multi-step reaction. Notice in the chemical mechanism, the intermediates disappear towards the end of the reaction. Therefore, intermediates are not considered the reactant or product. Notice there's an iodine ion that appears in the beginning of the reaction and the end of the reaction. This iodine ion comes from the potassium iodide, which is the catalyst in this reaction. The catalyst is neither a reactant or product, since it does not get consumed during a reaction. So when a catalyst is added, you can recover the catalyst at the end of the reaction. Here we have a diagram in which we're pouring water through a series of funnels. During the process of pouring water, which is the slowest step? It is the step with the smallest funnel. Water going through the smallest funnel is the slowest step in the process. As you can see from this diagram, this slowest step controls the rate in which water is poured. This slowest step is known as the rate determining step. It determines the rate of the reaction. Here's another diagram illustrating this. This opening is the most narrow, therefore it is the rate determining step. It is the slowest step. In the context of a multi-step reaction, which has multiple steps, the rate law of the multi-step reaction will be based off the rate determining elementary reaction. Let's say in a multi-step reaction, the first step is a slow step. And since this is an elementary reaction, the coefficient is equal to the order. So this will be the rate law. Capital A and B are the reactants. Lowercase a and b are the order. Lowercase a and b came from the coefficients of the elementary reaction. Keep in mind, you can only do this if the slow step is the first step. For example, if this slow step was not the first step, then this will not be the rate law. You have to do some substitution, and I'll show you later. Learning check number 1, which is the rate determining step in this hypothetical reaction mechanism. Pause the video, resume as completed. The rate determining step is the slowest step. That'll be step 1. Learning check number 2, which is the rate determining step. Pause the video, resume as completed. The rate determining step is the slowest step. That'll be the one with the highest activation energy. So the answer is step 3. Given the following mechanism of a reaction consisting of two elementary reaction steps, write the overall reaction. To write the overall chemical reaction, we have to combine step 1 and step 2. We can cross out the same substance on the reactant and product side. For example, NO2 is on the reactant side in step 1, and NO2 is a product on step 2. NO3 is a product in step 1, and a reactant in step 2. We can also cross them out. Next, we combine step 1 and step 2 to get the overall chemical reaction. What is the intermediate in this reaction? That will be NO3 because it was formed during the reaction, and then it disappears in step 2. To find the rate law of this multi-step reaction, we have to look at the slow step. In this example, the first step is the slow step. This will be the rate determining step, and the rate law will be based off this step. Since there's only one substance on the reactant side, the rate law is only based off NO2. Since there's two NO2, the coefficient is 2. So the order of NO2 in the rate law will be 2. So this is the rate law. Learning check number 3. Given the following mechanism, which substance is the intermediate? Pause the video, resume as completed. Based off the mechanism, there are 2 steps. Notice in step 1, AO2 is formed, but in step 2, AO2 disappears. Therefore, AO2 is the intermediate in this mechanism. Learning check number 4. Given the following mechanism, what is the rate law? Pause the video, resume as completed. The rate law is based off the slowest step, which is step 1 in this mechanism. The reactants in step 1 is A and O2. The coefficients of each substance is 1. Therefore, both substances have an order of 1. So the answer is choice 2. Learning check number 5. Given the following mechanism, which substance is the catalyst? Pause the video, resume as completed. If you recall from page 6, catalyst is not used up and can be recovered in the reaction. If we combine step 1 and step 2 to get the overall reaction, we can see that A was added in the beginning, but was used up during the reaction, but was recovered at the end. Therefore, A is the catalyst in this reaction. Learning check number 6. Given the following mechanism, what is the rate law? Pause the video, resume as completed. The rate law is based off the slowest step in the reaction, which is step 1. Step 1 has 2 reactants, HBr and O2. The rate law will be based off those 2 substances. Both HBr and O2 have a coefficient of 1, therefore the order will also be 1. So the answer is choice 4. Try to do questions 2 to 7 by yourself. Pause the video, resume as completed. Here are the answers. For question 8, notice that the slow step is the second step in the mechanism, not the first. Let's first write the overall chemical reaction and combine step 1 and step 2. N2O2 is cancelled out, so N2O2 is the intermediate in this reaction. The rate law is still based off the slowest step in the mechanism, which is step 2. Notice that N2O2 is included in this rate law. This is a problem because N2O2 is not a reactant, but an intermediate. Intermediates are formed during the reaction. A rate law is based off reactants, not products, not intermediates. Therefore, we have to use some substitution. If we look at step 1, NO and N2O2 exist in a 2 to 1 ratio. Therefore, NO to the order of 2 is equal to N2O2 to the order of 1. We can substitute this into this rate law. Therefore, the rate law of this mechanism is this. Notice that NO and O2 are reactants in this reaction. Try to do questions 9 to 10 by yourself. Pause the video, resume what's completed. Here are the answers. This concludes the video lesson. Remember to do the homework.